that is above iron in the electrochemical series. Take note of that. So let's see our options. Option A, silver. Look at where silver is. Silver is here and iron is here. So you cannot quote iron with silver because silver is less reactive than iron. And silver is also what? In that situation. So silver cannot be used to coat iron to prevent it from what? Corrosion, because silver is less reactive than iron. Then let's see other options. Option B, copper. Look at where copper is. Copper is also below hydrogen, below iron. So this one is out, this one is out. Then the next one is zinc. Then zinc is above iron. So zinc can be a solution to that. You can use, and that is what is known as what? Electroplating. So you can use this zinc to coat this to prevent it from what? Rusting. Since this, because of the fact that this one is susceptible to what? Corrosion. So by using it to coat this, it will prevent this from what? From being corroded or from undergoing what? Corrosion. So zinc is a suitable option. Then gold. Gold is also below it, so it cannot be. So the suitable option there would definitely be zinc. So let's see which option is zinc. That's option C. So option C will be the suitable option for question 7. Then the next question, a noble gas with high power of fault penetration using aerodrome beacons is, we just did that now, and that is what? Neon. We check what we did. That's the last slide, is on the last slide. So that is definitely what? Neon. Because it has, and why it is used in aerodrome beacons is simply because it has a high fault penetration power. So the mist can penetrate through it. And that is why they use it in what? Aerodrome beacons. So the option there will be option C. That is neon. Then question 9. The major source of oxides of nitrogen is from burning of A, coal, B, wood, C, fuels, D, CFCs. CFCs means chlorofluorocarbons. So the major source of oxides of nitrogen is from burning of what? Fuels. That means when you burn, when fuels as if fuels, when you call fuels or you pronounce as fuel, is burned. That is where you have a major source of oxides of what? Nitrogen. So that answer, the answer to that question will be option C, which is fuels or fuels. A gas that is not associated with global warming is A, carbon dioxide, B, sulfur 6 oxide, C, methane, and D, hydrogen gas. So in this situation, the one that will not be associated is CO2 because of the fact that CO2 is a stable oxide and it's also an heavy oxide. So in that situation, it's only when you have an unstable compound that you can have a reaction. So carbon dioxide is stable at this state. So that is why it will not partake in what? Global warming. Every other one you have them, they are unstable, which after on reaction with another species, they give a product. So with global warming, hydrogen gas is involved, methane is involved, then sulfur 6 oxide is involved. So the only one that is not involved is carbon dioxide because of its what? Stability. Then also question 11. The air pollutant unknown in nature is A, DDT, B, carbon 2 oxide, C, methanol, then D, NO. So if you look at this option very well, you will discover that DDT, we are familiar with CO. CO is known in nature. Then methanol is also known in nature because this is the first member of the alkyl series. Then NO, that's nitrogen 2 oxide, is also known in nature. This is the only oxide that is this is the only compound that is not known in nature. And DDT is diphenyl, trichloroethane. It is a synthetic compound that is used as what? Insecticides. They use it as what? Insecticides. it persists in the environment and it concentrates more in, it has more concentration in animal, especially at the head of the what? The food chain. So actually in some countries it has been banned. It has been banned in some countries because of it, because of the fact that it is hazardous. That is why it is unknown in nature. So the answer to that very question is DDT, and DDT is found at option A. That's option A, that's DDT. So option A is a suitable option for question 11. The next topic is water. Water is another topic under this syllabus. We have composition by volume. Composition by volume. So you have water when you have the mixture of what? Oxygen and nitrogen in this ratio. Then you have a scenario like this. So let's say this is a gas, and let's say you have a gas. And this is 2:1, although if it's water you're talking about, that's will be liquid. But again, that's 2 ratio. So you have 2:1:2 ratio. That is the composition by volume. Then water as a solvent. Atmospheric gases dissolve in water and their biological significance. Water as a product of combustion of hydrogen, and that is what you have. So combustion of hydrogen gives this, and the ratio is 2:1:2, hard and soft water. Then if you are talking about hard water can be classified into two. You have permanent hardness. Then we have temporary hardness. So when we talk about hard water generally, we say it contains ions of calcium 2+, calcium ion and magnesium ion of hydrogen carbonate itself, then sulfates. So what is responsible for hardness in water is as a result of what? Calcium, magnesium ions of these respective radicals. That is what is responsible for what? Hardness in water. But if you are to talk about permanent and hardness and temporary hardness, we are talking about temporary hardness. Temporary hardness is as a result of calcium 2+, magnesium 2+ of hydrogen carbonate and carbonate itself. But if you are talking about permanent hardness, then we'll be talking about calcium 2+, magnesium 2+ of sulfates. Take note of that. So that is what. So if you're talking about temporary hardness, you have hydrogen carbonate and carbonate. But if you are talking about permanent hardness, it will be calcium ion and magnesium ion of what? Sulfates. Then we talk about soft water. Soft water is one that has a low concentration. That's a low concentration of ions. But the major components that make it soft is because of the fact that it lathers easily or readily. It forms lather easily or readily with soap because of the fact that the ions that make it hard, those ions that make water hard, are not present. So that is majorly on that. Then also we talk about temporary and permanent hardness and method of what? Softening hard water. Then if you are talking about permanent hardness, These are the ions and the cations that are what? These are the ions, that's the cations and the anion that is involved. When you see sulfate of ion of this or this, then that's such a water is said to be what? Permanent what? Hardness. So also, what are the methods that can be used to remove any of the hard water that can be used to soften hard water? In that situation, let's talk about temporary hardness. We can do that by boiling. So because by boiling, you can remove temporary hardness of water. And temporary hardness of water, such as what you are having here, by the time we boil this, then we have CaCO3 plus water, then plus CO2. That is one way by which we can remove, and this one can become the precipitate that will now be what? Filtered off. So that's one way of removing temporary hardness. Another way is by using slaked lime. We can also use what? Slaked lime. So if we use slaked lime, we can also remove it. CaCO3 plus slaked lime. So here we have CaCO3 plus H2O plus CO2 also. We have something like this. So that's another way of removing temporary hardness of hardness of water. Then if we are to talk about permanent hardness, we cannot remove permanent hardness by boiling. Take note of that. We cannot remove permanent hardness by boiling. One way of removing permanent hardness is by the addition or the introduction of sodium hydroxide. So we can remove permanent hardness by